Okay, good morning class. So today we're looking at Euclidean Geometry exercise 9.3. We're looking at numbers 5 to 8 now. Okay. So we are given that AD is the diameter of the circle center O. People, if AD is your diameter, what do we know? We know that B is 90 degrees. Not so. Why? Angle in semicircle. Okay. Then we are told that B is the point circumference of the circle and BC is perpendicular to AD. So there's your 90 degrees. B1 is 41 degrees. The question says work out B2. So how are you going to work out B2? It's going to be 90 degrees minus 41. Okay, so it's going to be angle B2 is equal to 90 degrees minus 41. The reason? Angle in semicircle. Give me an answer of 49 degrees. Okay. Let's look at B. Is to work out D. So what can we do here? Exterior angle is equal to the sum of the two interior opposites. Not so. Or you could have worked out C2 angles on the straight line and then sum in triangles. Not so. So I'm going to say for B is going to be C1, which is 90 degrees, equals angle D plus 49 degrees. Reason? Exterior angle of triangle. And is the exterior angle of triangle CBD. Okay, so angle D is going to be 90 minus 49, which is 41. Okay. So any confusion there? Alright. Let's look at the next one. Question 6. Given ABD and COD are diameters. Okay, so if AOB is the diameter, what do we know? Let's see, 1 and 2 is 90. If DOC is the diameter, what do we know then? That A1 and A2 is also 90. Why? Angle in semicircle. Not so. Then we are told that C1 is 33 degrees. That's indicated there. Calculate the size of O3. So now we're going to calculate O3. Angle at center. Double angle at circumference. Not so? Right. So let's go with that. So angle O3 is equal to 66 degrees. Why? Angle at center is equal to 2 times angle at circumference. Okay. So 66 lies there. Let's look at B. B, they want to calculate angle D. So how are you going to get angle D? Straight line. Oh, O2, yes, straight line. Okay, I see now. And then? Angle at center is twice angle circumference. Not so. You all agree with that? There's another way. You'll get full marks with that anyway, yeah? There's another way. Sum in triangles. But what do I need? I need A to be 90 degrees. So what do I say? CAD is equal to 90 degrees. Why? Angle in semicircle. So angle D is equal to 180 minus 90 minus 33. Reason? Sum of triangles, and its triangle CAD AD. Okay. Sorry? Okay, so we give you an angle of 57 degrees. Angle B. There are many ways to work out B now. No? It would have actually been easier if I had gone and worked out that angle first, for angle at center twice angle at circumference, because it would have been exactly the same reasoning. Can you see that? Angle at center is twice angle at circumference again. You guys understand? But okay, since I didn't take that route. Sorry? You can use straight lines, he says. Okay? How else are you going to calculate B? So we're going to go with that one. So we go with O2. Angle O2 is equal to 180 minus 66. Why? Straight line. Which gives you an answer of 114. Okay, and now angle at center is 2 times angle at circumference. The angle B is equal to half times 114. I'll give you an answer of, sorry? 57. The reason? Angle at center is equal to 2 times angle at circumference. Okay. What I could have also done was, I could have said this is 66. Why? But it's the opposite. And then angle B is equal to angle C2. Angles opposite equal sides. And then sum in triangles. Okay. There's another way. I could have said that is 90 degrees. Not so. Then I work out this angle here. 90 minus 33, which is 57. And then this is 57. Why? Angles opposite equal sides. Understand? That's why what makes geometry so easy. No? There's many ways of solving the same thing. Alright? People, let's look at question 7. Two circles touch internally at P. Okay, well, it's in the inside. O is the center of the larger circle and OP is the diameter of the smaller circle. Read it again. O is the center of the larger circle and OP is the diameter of the... People, if OP is your diameter, then what do we know? That PAO is 90 degrees. Now if we got the circle here, oops, if we got a circle, we have a circle now, and from the center to that point, this is 90. And what do you know about PQR? PQ is equal to QR. Why? Perpendicular from center to chord by 6 the chord. Not so. So what do you notice here? That this is 90. So what can we conclude? This is 90. What can we conclude? AP is equal to AB. Why? Perpendicular from center. Let's read the equation. Oh my word, they asked us exactly that. Now I'm upset. They're making things too easy for us, no? I know you guys want a challenge. No? Right. And they ask you exactly to prove that PA is equal to AB. So how do we do that? We firstly say that PAO is equal to 90 degrees. Why? Angle in semicircle. And now we can say therefore PA is equal to AB. Why? Perpendicular from center to chord by 6 the chord. We'll cut the chord in half. bisects the chord. Okay. Any confusion? Alright, so let's look at number 8. That's the last one. The question says, given LM is the diameter of the circle. So angle at, if this is the diameter, then this here would be, this angle will be what? 90. Why? Angle in semicircle. Not so, but that line wasn't given there. No? Is it given?
In the book.
The book I have is probably an older book. So, okay, that should have been it. Right. That makes more sense. So there's going to be 90 degrees then. Why? Angle in semicircle. Now, without going any further, what does this shape remind us of? Triangle, yes? Midpoint here. Can you see that as long as those lines are parallel? If you got A, B, C, D, E. If these lines are parallel and this is equal, then what can be concluded from here? AB is equal to BC. Why? Converse of midpoint here. What else do we know? The DC is double BE. Why? Converse of midpoint here. Not so. So in this case, you got LR and RP. But these lines are not equal. These lines. Okay, these angles are equal. So it makes these lines parallel. And if those lines are parallel, what do we know? LN is equal to MN. You see that? What else do we know? That MR is equal to half PN. Or PN is going to be double MR. MR is half of PN. And PN is double MR. Then that's, you see that the other way around. No? You guys see how easy this stuff is? I'm upset now. It's so easy. No? Right, let's continue reading. Let's take the fun out of reading. Alright. So we told that LM is the diameter of the circle. Chord LP produce. What does produce mean? Extended. Chord LR, produce is only to P. NP is drawn perpendicular to LP, which is there. To cut LM, produce in N. Okay? The question says, right. So where do we start? You start off by saying L or M is equal to 90 degrees. Why? Angle in semicircle. Alright. With that, we can now see that these lines are parallel. Why? Because the corresponding angles are equal. Are you guys with me? Am I moving too fast? No, okay? So these lines are parallel. So MR is parallel to NP. Why? Because corresponding angles are equal. So now I place straight into the midpoint theorem. Okay? So we can say therefore LM is equal to MN. Why? Because of the converse of the midpoint theorem. The converse of the midpoint theorem. Alright? Any confusion there? No. So you got 3 sums left, not some of this exercise. Right, we'll do that in tomorrow's video. Okay? Or in tomorrow's lesson.